Hello, I am Jim Haldeman with the Kelly Industrial Automation Group. Thank you for participating in today's webinar entitled Avoiding Instrumentation Pitfalls with Custom Engineered Solutions. Today's presenter is Tom LaPlante. Tom currently serves as the Director of Product Solutions for Kelly Industrial Automation. In this role, Tom supports the Kelly Industrial Sales team on any number of industrial control applications requiring instrumentation, automated valving, control systems, and industrial heat tracing. Tom especially enjoys working directly with customers to help solve and improve their process control needs. Tom's career of some 30 years started with AC controls, AC Technical Services as a field technician, and quickly moved into the roles in project management and technical sales for automated process control and combustion control systems. For the past 10 years, Tom has worked to improve the instrument, automated valve, and UL508A industrial control panel offering by AC Controls, a Kelly company. Today's webinar will be recorded to allow others to see the presentation. Please use the question box below to ask your questions. I will see them, and I will ask Tom your questions on your behalf. Tom, please begin your presentation.
Well, thank you, Jim, and welcome everyone. I can honestly say this is my first Halloween webinar. So happy Halloween to anybody that's out there. I'd like to thank all of you for just taking a few minutes out of your day to spend with us and discuss industrial instrumentation and the solutions that Kelly Industrial can provide for you. As Jim said, I've spent the last 30 years working with AC Controls and AC Technical Services here in North Carolina in a variety of roles, all of which had me working on a daily basis with some type of process control, instrumentation, or valving. Typically that involved applications for systems automation, for manufacturing process control or combustion control, even burner management systems for boilers and the like. About 12 years ago, our company expanded and formalized our offering for industrial product solutions by investing in growing two parts of our three-part shop approach for valves, instruments, and industrial panels. And I had the privilege of leading that effort. We'll talk more about that later, so for now, let's get started. So here's our agenda for today. We'll start by talking about industrial instrumentation, and this will be where we spend the lion's share of our time. Because our time is limited, we'd like to focus on one area in particular, and so we'll spend a little time talking about instrumentation and remote diaphragm seals in particular. In this section, we'll review pressure instrument types, particularly those that are commonly used and approved for use with diaphragm seals. We'll look at an overview of diaphragm seal types, common accessories, and the anatomy of a diaphragm seal. We'll look at some instrument seal assembly types. And finally, we'll talk briefly about common errors and pitfalls we most commonly see and the problems that they present. And then we'll discuss proper application and the critical information you'll need in hand when you come to us requesting a seal instrument solution. To end our short time together, we'll look at a summary of the variety of engineered solutions that Kelly Industrial can provide. We'll briefly review our shop solutions as well as our technical field services capabilities and how you might consider using that resource if needed. After all this, we'll make time for any questions you may have. I won't be looking at the chat, but our host, Jim Haldeman, as he explained, will help us when the time comes. He may even interrupt me if he feels there's an important question to address. So please don't be afraid to ask a question in the chat. There is no wrong question. There can only be wrong answers. And finally, if time had allowed, was going to show you a featured product for the day. I've decided against that. we're going to make this as efficient as possible and try to enjoy our time here and learn a few things together. So probably the most common pressure instrument to have a diaphragm seal applied to it is the process pressure gauge. We could spend an entire class talking about pressure gauges and the various types that there are. As a matter of fact, if you'd like more information on mechanical gauges, there's a short webinar recorded at the Lessman Kelly Industrial Training site under pressure devices. As a matter of fact, there are several webinars there, even one on diaphragm seals that makes a much deeper dive into diaphragm seals than we're going to do here today. So I highly encourage you to make use of that training resource. There are limitations to applying diaphragm seals to gauges. First of which, we typically only see seals applied to board-on-tube pressure gauges and not to direct drive gauges. Differential and gauge pressure transmitters are very flexible, and with few exceptions, they can accept almost any diaphragm seal. Their limitations are generally with maximum capillary lengths. It's probably the most significant limitation. The final category of pressure instruments are mechanical and smart pressure switches. Mechanical switches tend to be a little bit like gauges in that not every mechanical pressure switch can accept a seal. Smart pressure switches, on the other hand, they have virtually no limitation, as they tend to mimic pressure transmitters because that's really what they are. They're pressure transducers. In terms of accuracy, gauges and switches are typically 0.5 to 1% devices, whereas pressure transmitters, they're far, far more accurate. And they're in the range of 0.055% to say 0.025% of the span. One final item on pressure instruments. Diaphragm seal connections to these devices will either be threaded or welded. It's worth noting here that our preference here at Kelly is to supply you with a device that has welded instrument connections. It's not always possible, and before anybody asks the question, no, we do not back weld over NPT threads. Let me say it again, we do not back weld over NPT threads. It is permissible in some cases to do that, but we just don't care for the appearance. So now let's get on to looking at some of the most common diaphragm seal types. The threaded offline diaphragm seal is one of the most common seals you'll see because it's so easy to assemble. The bad thing, it's just as easy to disassemble. Many times we've seen where a plant maintenance unintentionally or unknowingly put their wrench on the gauge instead of the seal. And as we all know, once the seal is broken, it will have to be refilled. The flanged offline and the flanged flush face seals are the most common diaphragm seals that we typically stock. We'll take a closer look at those in just a moment. The flanged extended seals are ideal for highly viscous fluids or media with high solids content. Extended diaphragms for flanged nozzles and dead legs are typically found on tanks. Typical extension lengths for these are 2-inch and 4-inch and 6-inch, but they can also be made to custom outside diameters and extension lengths. The diameter of the one you're seeing here is about 3.5 inches. Locally here in North Carolina, we have a rather large meat supplier that uses these to measure level on hog guts processing tanks. The extended seal is just long enough to reach close to the inside of the tank, and the extension avoids clogging in the nozzle dead leg. Next, we have the all welded mini seal, which comes in diaphragm sizes of 1.5 and 1.9 inch diameters. The welded seal body eliminates the need for any gaskets. which also reduces the probability of failure and removes potential chemical compatibility issues. The standard threaded instrument and fill port connections make assembly and filling simple and provides an affordable option to protect your instrument. And the last seal I'll mention today is the flow through, or what we call the ISO ring seal. Now, these are ideal for highly viscous media that may have high solids content, mainly used in municipalities for wastewater, and they come in ANSI 150 and 300 sizes for wafer and through bolt styles, as well as NPT threaded versions even. The significant volumetric displacement for these seals allows for multi-instrument configuration options where you can install a gauge, a switch, and even a transmitter, all on a single seal. We'll see an example of that in just a moment. The full bore or zero pressure drop design of these seals make them the perfect candidate for measuring pump discharge pressures. There are two other seal types I'll mention here, both saddle seals and button seals. We do see plenty of each, but they are less common than most, and we've only got so much time today. Ultimately, the purpose of a diaphragm seal is to protect the pressure instrument from heat, corrosion, and most importantly, clogging. The potential for clogging from high viscosity process media or fluids with solids in them is one of the primary reasons for using a diaphragm seal. The seal is also intended to protect process fluid from non-clean out dead legs. What we mean by that, an example would be a small diameter pipe nipple, or say the nozzle on a tank with no flushing capability. Seals also protect against instrument contamination on the process side of the seal. A good example of this would be in the food and beverage industry, where the smoothness of the piping internals and any connected devices is regulated. In those cases, we would use a sanitary diaphragm seal. If you're familiar with this, you would know it as the RA rating of the face of the diaphragm. We'd also select a fill fluid in those cases that would not be toxic, such as niobium 20, glycerine, or white medicinal oil. We'll talk a bit more about fill fluids in just a bit. Ultimately, our goal should always be to have a properly specified and well-built diaphragm seal system that accomplishes this without compromising instrument performance and reliability. So I did tell you we'd take a closer look at two seals in particular, and here we'll look at the flush flange seal that comes in sizes 2-inch, 3-inch, and 4-inch, and they also come in several pressure classes, though ANSI 150 and 300 are the most common. These seals are ideal for highly viscous fluids.
Tom, we have a question. We have a question I wanted to ask you. When you mentioned 2-inch, 3-inch, and 4-inch, are you referring to the diameter of the seal itself, or is that the flange process connection?
Yeah, great question. I did say, and maybe we should type this in the future, it's 2-inch, 3-inch, and 4-inch ANSI 150 or 300. They are made in higher pressure classes, but yes, that is the pressure class of the seal. Did that answer the question?
Yes, thank you.
Yeah, no problem. The limiting factor is the diaphragm size. It's really restricted to the process connection. You can only get so large with the diaphragm before you start impinging on the raised face. This particular flush flange seal can be made in two styles, both as a single piece, which is very common, or the rotating ring design, which a lot of people appreciate when they're mounting them to their tanks. The predominant size we see on industrial applications is a 3-inch ANSI 150. And so we here at Kelly, we work to keep at least 4 of these units on the shelf at all times for quick delivery. The flanged offline seal is ideal for applications utilizing small flange sizes, but also requiring high accuracy. The offline, we talked about it with threaded offline or with flanged offline, but the offline description for these seals, it's simply a reference to the lower section underneath the diaphragm. You can see the lower called out in the 2 drawings shown here. This allows us to use larger diaphragm sizes for high accuracy and lower pressure ranges for the smaller connections. And as a matter of fact, with these sizes, whether it is a 1/2-inch connection or a 2-inch connection, we can use even the largest diaphragm size, which is 4.1 inches. They contain an additional process wetted gasket at the lower and a spacer ring to adapt a small flange size to a larger, more sensitive diaphragm. For very small sizes, a stud bolt option is available for low pressure ranges that still require a large diaphragm. Again, typical sizes for these flanged offline are 1/2-inch through 2-inch for ANSI pressure classes of 150 and 300. Though, once again, we have seen higher pressure classes requested for 600 and ANSI 900 and so on. Some of the most common diaphragm seal accessories we stock and use on a daily basis are armored or PVC coated capillaries. Capillaries allow for the instrument to be mounted remotely so that they can help limit exposure to process temperatures and vibration. There are limits to the lengths that we can use, and our primary concern is to always limit the amount of fill fluid we have in a diaphragm seal system. More fill fluid basically equals more opportunity for the sensor to drift and have error due to temperature fluctuations. And I will add here, that's a particular concern when you have a device that is mounted outside. Days like today in the fall, where it's cool in the morning and warm in the afternoon, can cause drift on a remote diaphragm seal. Another helpful accessory we often use are cooling towers. Here we're showing a 6-inch and a 4.5-inch tall unit. We typically use these between the instrument and the seal, but they can also be threaded directly into the process media as long as the application has a fluid that is viscous enough to flow through a 3mm ID tube without clogging. So you wouldn't want any solids in it. These are not recommended at all for steam service. In those cases, you would most definitely want to use a siphon. Flushing or bleed rings are used with flanged diaphragm seals, particularly the flush flange, but they're used for flushing or venting the process fluid or to provide access for field calibration. Though typically used on flange seals, we've even seen some folks use these as a pressure tap on the inlet or outlet of a flanged valve. So now let's take a quick look at some assembly types. As we said before, process gauges are the most common assemblies you'll likely see in the field. Some call these gauge isolators. Pressure switches often need isolation and protection. We'll talk a bit about some of the challenges, particularly for switches. But in our experience, we've had more opportunity to help our customers with gauge and differential pressure diaphragm seal assemblies. I'm not 100% sure why that is, but I do suspect it's likely because most manufacturers have a very long lead time for these types of assemblies. We, on the other hand, stock a lot of transmitters and seals, and if we have all the components, we can even turn these around in say 24 to 48 hours. The last assembly I'd like to show you is an isolation ring seal, or an ISO ring as some call it. In this photo, you have an example of a multi-instrument assembly mounted on a goalpost style connection. You can't see it here, but these seals come with what we call an IQD, or an instrument quick disconnect. It's basically a hydraulic connector, and that allows for isolation of the fill fluid in the seal and for the instrument or instruments. We actually fill this seal and the instrument separately because of this connector here in our shop. What's really cool about that, we can supply spare instrument assemblies that you can put on the shelf and can replace these in the field without having to remove the seal from the process. The sizes for these rings, by the way, goes from very small up to at least 24 inches. Well, as you can imagine, there are literally hundreds of assembly types, and we could spend all day showing you examples. But I'll show you just one more. What's interesting about these pressure switch seal assemblies with cooling towers is that our customer was local, but the end user was in Dubai. The process media that's being measured had a very high temperature. I'm not exactly sure, but I believe it was around 750 degrees constantly. So the end user was directly involved in the approval process. So we provided them with an assembly drawing. The approval process took about 2 weeks for the drawing, and delivery of the finished, tested, and tagged product took 3.5 weeks. In fact, our engineering customer was so pleased, and he said if this required him working directly with a manufacturer, it would easily have taken double that time. So being a local stocking distributor with engineered solutions has really allowed us to improve our speed to the marketplace. We'll talk more about that later. So let's quickly go through the anatomy of a diaphragm seal. The seal, of course, is a welded seal, but it has all the basic components of most diaphragm seals. The diaphragm is the most crucial element, of course, and in order to transmit process pressure effectively and accurately, it has to be very thin. Most diaphragms are only 0.003 of an inch thick and are very fragile. Though not all seal models have a lower housing, the ones that do allow us any number of a variety of threaded or flanged process connections. They also serve to protect the diaphragm, of course. The upper housing is part of every diaphragm seal, and because it's not a process wetted component, we can usually specify non-exotic material like 316 stainless steel or nickel-plated carbon steel. It's worth noting here, though, carbon steel is lower cost. We almost always recommend going with a 316 stainless steel upper housing. It usually adds about 2 weeks if you want to have carbon steel that's nickel plated, and that's of course going to slow down delivery to you. And finally, we have the instrument connection. Again, 1/4 inch or 1/2 inch MPT female threaded connections are very common, but as I said before, whenever possible, we much rather prefer to supply you a welded connection. There's obviously, when we do that, less opportunity for the assembly to fail from fill fluid leakage if you have a welded connection. So now that we've reviewed some basics about pressure instruments with diaphragm seals, let's talk for just a bit about some of the common errors when specifying seals. For seals that fail, we often see the wrong wetted material used. For optimal corrosion resistance, selecting the right seal material is absolutely key to having a robust seal system. The photo on the left is from one of our larger customers, and they have a lot of very aggressive chemicals at their plant. This particular application involved using a large diaphragm flanged offline seal to measure sulfuric acid pressure. The material selected here was actually very sound and is typical for sulfuric acid. A tantalum diaphragm with a Hastelloy C lower, or in some cases, you might even use a tantalum lined lower. It's very typical. But I believe the purity of this particular sulfuric acid was very high. And as you can see, the end result of how the process affected the diaphragm, it just kind of ate it away. This particular application was frankly very good business for us. Every 6 months or less, they would order a new batch of pressure seal assemblies. These are actually on pressure transmitters. So after a few years of doing this, they came back to us and asked if there was a better, more durable solution. The photo on the right shows a solid Teflon diaphragm and a solid Teflon lower. I don't want to mislead you. There are challenges when you're working with non-metallic diaphragms. Over time, they can sag or they can cold flow, as they say. Teflon is also just a bit porous, and so process media over time can eventually migrate into the seal cavity. But the result is that they now have assemblies that are lasting up to 4 years. As a matter of fact, we had to make a phone call to see if they were still using seals. They were lasting so long. This example here is a perfect example of a real solution for a real problem. So ultimately, there's a wide variety of metallic alloys, 316 stainless steel and Hastelloy C276, probably the most common. And there's also some non-metallic ones, like we mentioned, the Teflon, that are available to us to help you protect your instruments against corrosion. Pressure, process temperature, and chemical compatibility are the preeminent factors when choosing the right material. Choosing the wrong diaphragm size is also a big problem, sometimes more common than choosing the wrong material. When considering diaphragm size, we need to know that the diaphragm can displace enough fill fluid to actually drive the instrument, whether it's a gauge, transmitter, or a switch. The diaphragm must also be sensitive enough to measure the applied pressure from the process. And finally, the diaphragm must be sensitive enough to absorb the small expansions and contractions of the fill fluid that come due to temperature change. We'll see in a moment why this is important. Diaphragms overall are offered in 0.7 inch, 1.5 inch, 2.2 inch, 2.9 inch, 3.5 inch, and 4.1 inch. And the variety is there to allow for the most efficient transmission of pressure, depending on the range and what the instrument actually requires. So let's talk now about another crucial element of good seal design when looking at diaphragm size. Volumetric displacement. A diaphragm acts really as a barrier between the applied pressure from the process fluid side to act on the fill fluid side, and then ultimately to the instrument. A diaphragm seal coupled with an instrument really is simply a mini hydraulic system. Every pressure instrument has a specific volumetric displacement required for full span operation. Those volumes are generally published by the manufacturer and available to us for design purposes. Sometimes you have to ask, but most do publish them. Ultimately, the basic rule of thumb is the best operation for a diaphragm seal. It requires a 4-to-1 ratio of the diaphragm system volume to the instrument displacement volume. Simply put, the more volume required to make the instrument work, the larger the diaphragm you're going to need to drive that. When looking at diaphragm sizes, instrument pressure limitations are also a factor. The instrument pressure range must also be a consideration when selecting a diaphragm size. The lower the pressure, the more surface area that's required to affect a change in the movement of the diaphragm. We commonly refer to that as the spring rate.
Tom, I have one question I'd like to ask.
Go ahead.
What is a symptom that a customer might see when they've selected the wrong size diaphragm?
Yeah, good question. Well, I'll tell you the worst case scenario is it wouldn't get out of the shop that made it because it actually wouldn't be able to do the work. Funny story, 10, 15 years ago, whenever we first started this, I did not look at the volumetric displacement of a switch. And we went through the whole process of buying the seal, assembling it, and filling it, only to realize that it was barely a 1-to-1 ratio. We did have a way around that. I don't mention it here in this class, but we did have a way around that. And there are ways to cheat, as it were. But a lot of customers have found, they basically find it by looking at other pressures. For example, they may have another transmitter down the stream that's reacting properly, and then when they see a sluggish response on the transmitter seal that they've installed, that's generally how they might know. In other words, there tends to be a little confidence crisis in what's being reported by the instrument. So yeah, not working at all would be the worst case scenario. Being sluggish or slow to respond would be another one. You know, for example, if we tried to take and measure a span of 5 psi, and we used a 1.5-inch diameter diaphragm seal. Not a whole lot of science in this, but it's a small diaphragm seal, and that's a fairly low pressure. You know, that's really, it's just never going to work. So I don't know that I answered your question, but sluggish response, unbelievable response from your instrument, probably an indication that it may be.
So just to add on to that, is it safe to say, or is it a true statement to say that when Kelly Industrial sees an inquiry for a specification that might have a transmitter with a specific size seal, this is something that you would look at and review to confirm that what the customer selected will indeed work, correct?
That is true. As a matter of fact, I've always tried to be efficient with any presentation. Just because death by PowerPoint is a slow death sometimes. I was going to pop up one of those sheets and kind of talk about that. I'm glad you asked the question, though. Whether it's me, and frankly, we have others in our solutions group that are doing this work. We don't take it for granted that the engineer that designed that equipment actually knew what he was doing. So we do look for those types of things, and we're coming up in a minute here to talk about some of that. So great point. You're kind of getting a little ahead of me, and that's good. Shows we're thinking a little bit. So small diaphragms are used only when the system volume and the pressure ranges allow, since their spring rates are so high. In other words, higher pressure gauges, 200, 300, 500 pounds and above, we can use much smaller diaphragms. It's safe to say that any instrument requiring inch water column measurement will require the larger size diaphragms. In fact, there are gauges that have direct drive diaphragm gauges, and those are made specifically for low pressures. We don't put seals on those because those typically are a seal, or we typically don't do that, I should say. When you're looking for solutions, when you come to us, if you don't have an application data sheet or an instrument data sheet, not a problem. just always come ready with your application minimum, normal, and maximum pressures. And for that matter, the temperatures too. We need to know both. Choosing the wrong system fill fluid and or a lower gasket is also a pitfall we sometimes see. A bit hard to see everything here that's a bit intentional, but for fill fluids, we have multiple options available, ranging from sanitary food grade fluids to inert fluids and even high temperature silicones. The chemical interaction with process media is the first factor to consider when the diaphragm seal fails. Oxygen service, for example, requires inert silicone-free system fills to avoid what we call in the industry rapid thermal expansions. We don't like to use the explosion word. Temperature range of the fill fluid is the second consideration when you're selecting fill fluids. More importantly though, what is the process temperature at your pressure range extremes? In other words, if you need to measure from vacuum to 200 pounds, we need to know that because the high temperature applications at vacuum or low static pressures, they'll actually reduce the upper temperature range of the fill fluid. Viscosity of the fill fluid can also impact what I call the flow rate in the capillary or the instrument connection, and that will actually affect the response time of the instrument. Didn't have notes here for this, but if you look at the middle of the page and you see food grade, you'll see glycerin USP. Its viscosity is 1100 centistoke, whereas silicone DC200 stands for Dow Corning Formula 200 silicone. Its viscosity, it does say 20 centistoke. It's actually closer to 10. Huge difference. You've got to be able to use that particular fill fluid, that glycerin, in the right application. You have to have large enough ID capillaries, and you really don't want it to be outside because that stuff gets cold. It's just not going to work. Simple things. Make sense? Gaskets also. This could be actually one where there is a bit of an issue because sometimes people just don't pay attention, but every gasket that's used between a diaphragm sealed diaphragm and the lower, it's made of a certain material and it has a temperature range. So they basically have a minimum and a maximum temperature limit, which is one of the things we first look at, particularly for seals that run hot. Next is obviously chemical resistance. You know, the diaphragm itself is welded to the upper. And so what's the weakest point of any diaphragm seal? Well, it's the weld. And so it's the weld of the diaphragm to the seal. The gasket itself, in part, works to protect that. So knowing your chemical compatibilities, the resistance of the gasket to your process, very critical. Cost can be a consideration sometimes. Most people ultimately don't care because they just don't want their stuff to leak, but cost could come into it, particularly for some of our silver and metallic gaskets. Those are generally used on high temperatures. A Klinger C4401, or what everybody in most plants calls green gasket, it's the predominant gasket used, and it's pretty effective. It goes from, say, 500 degrees down to negative 110 degrees Fahrenheit. Pretty flexible and can be used on a lot of organics and inorganics. Not a huge problem, but it's something to look at. What do I mean? Legacy engineering is a pitfall. What do I mean by legacy engineering? I'll keep it really simple. In short, all I mean by legacy engineering is simply always trying to replace a defective instrument to the same specification as the original. A lot of times our customers fail to consider that the device that's currently installed, it may not have been designed properly in the first place. This goes back to your point, Jim, on engineering, data sheets, whomever received that data sheet and made the seal for that application, whether it was a manufacturer or not, probably didn't have the whole story. So that's why we like to work with customers in our solutions group to get as much information as possible. And finally, improper installation. This is really a concern for the field, kind of after it leaves our building, leaves our shop. We sometimes don't get to see how our customers are actually installing their devices. But when it doesn't work, they're giving me a call, and so that's when the questions come. And so one example of this is for tank level measurement using a differential pressure transmitter. Often there's confusion over the high side and the low side seals of the transmitter. This can happen whether you're using diaphragm seals or not, I've found. But folks have to remember that the low side of a differential pressure transmitter, it's the draft side of the DP. It needs to go on the upper tap or the reference side of the tank. The high side, the working side of that assembly needs to go on the lower tap. Also, sometimes the transmitter installation height of the actual transmitter is above the lower tap. This can actually be done, but it's really not the best or the most common practice. When you mount above this tap, this will cause the actual high side fill fluid to actually run away from the transmitter, effectively creating a draft. You can do this, but calculations would have to be made, and effectively you're making a false range to be configured. Specific gravity and the like come into play with that. We've done it before. It just is a maintenance nightmare. So the best thing to do when possible is to keep that transmitter at or below the lower tap. Process media specific gravity. What's in the tank? Is it water? No problem. If you're measuring inches of water column, it'll work just fine. If it's corn syrup or jet fuel, each of which have different specific gravities, you're going to need to make an adjustment or compensate that range so that your inch water column measurement is seeing the actual level of the fluid. Probably one of the only shortcomings of using differential pressure on a tank, but it's a tried and true method. So these are just a handful of the common errors and pitfalls in selecting the right diaphragm seal for your system. You know, choosing the wrong wetted material, looking at the diaphragm size, fill fluid or the gasket, choosing the same old and not considering the original design. Ultimately, installing the device properly at your facility is the final hurdle for you to have a robust and a durable seal system. I'd like to talk to you for just a bit about our engineered solutions. We'll spend just a little bit of time here and then we'll be done. But when I talk about the variety of engineered solutions that Kelly Industrial Automation can bring to your team. Valve automation services. I know everybody says they've got a valve automation shop, but hey, we've been doing it for 60 years and we have earned a reputation for delivering quality and reliability to our customers in anything that we assemble. Our technicians, they're all factory trained, and they're factory trained on a number of products for valves, actuators, and positioners. We've developed the capability of being brand agnostic when we need to, and we can marry just about any brand valve with another brand actuator when it's absolutely necessary. Early on to do this, we invested in a custom hardware design. And for those 60 years, we have actually been designing hardware, brackets and couplings, particularly for quarter turn valves. And we also use local vendors to manufacture that. So we hit really quick turnaround. Our automation capabilities have grown over the years to allow us to work on just about any valve, to include rotary butterfly, ball valves, plug valves, knife gate valves, and we even have raised stem control valves. As you can see, we can handle large valves. The valves you're looking at in the upper left are 36 inches, I believe. But we can go from small 1/2-inch valves to that size. And I think actually the largest valve we've actually automated in our local shop is 54 inches. That thing was a hoss. Our warehouse is about 40,000 square feet, and it's stocked with an extensive range of valves and everything we need for valves, for components, for many different types of assemblies. This allows us to provide really quick turnaround to meet your urgent needs in particular. Our inventory is very carefully monitored so that we can ensure we have a wide selection of components on hand, if at all possible. We're stocked basically for a quick turnaround. I recently conducted an informal poll of our account managers and simply asked them what single feature of our valve automation offering they liked the most. Next to quick turnaround, most agreed it was our ability to be flexible to respond to our customers' needs and to provide exactly what they asked for. Most factory direct manufacturers who provide automation, they'll just not do that. We'll automate the whole valve, or as you can see here, we'll simply provide a pre-assembled automated replacement assembly. This here is a Morin actuator. I think that's an ASCO valve, and that looks like a Siemens positioner, and we stock and can make these stainless braided hoses with stainless fittings, which, by the way, is our standard for valves, hands down. We will do polytube if you want, but we moved away from that a long time ago. Panel design build services. It's the next area where we can provide solutions. We are a fully UL 508A industrial control panel shop. We have the certification. Each panel is designed to these standards, and UL labeling specifically for any given panel is available upon request. We give meticulous attention to detail, and given not only the design of your panel, but also the quality of each component we put into it, and to the wiring practices that we use. Before leaving the shop, each panel that we build, every panel, small or large, is fat tested for quality assurance, and that helps ensure that it's ready for your specific application, ready to go once it hits the dock. We offer a wide range of enclosure sizes, from small fiberglass polycarbonate panels to carbon steel to even NEMA 4X stainless steel to meet your standards. Whether you need a simple loop controller or a power supply panel, or if you require an entire control system panel or panels, our panel design build services are ready to meet the challenge. You've already seen a large part of how our instrument solutions and shop services can help you with regard to diaphragm seal instruments. We can also provide any number of prefabricated instruments like the ones you see here, where the instruments simply needed an ANSI flange added to it and a laser etch tag. The instrument shop is where we perform diaphragm seal welding and vacuum filling for instrument assemblies. All pressure devices are calibrated to NIST standards. We highly recommend that you allow us to pre-configure your instrument so that will allow you to have a ready to install device when it hits the dock. Evaluation and repair services for instruments and diaphragm seals is also something we offer. Sometimes it's not worth the cost, and a new seal is a better bargain, but for seals using expensive exotic materials like gold plating, Monel, and the like, it's really something to consider. We can also offer high quality laser edge tagging for any device you need. Just be sure to give us a list when you order your instruments. Finally, I'd be remiss if I didn't at least mention that we can offer directly at your plant site through our field services and tech support team. For as long as we've been in business, we have offered field service and technical support for emergency repairs, instrument and valve systems commissioning, and operator training even for automated process control. AC Technical Services is the group, and they use field technicians, a design group, and even project management to help bring you a total solution for any small or large control system need. And finally, just remember, in your journey with Kelly Industrial Automation, it begins with your local sales office. Reach out and connect with an experienced sales associate or your designated territory account manager. We are always ready to listen and work together to find a new solution. How about it, Jim? Any other questions?
Thank you, Tom. No additional questions at this time, but thank you so much for giving us your background and experience and history of some of the problems you've seen over the years and solutions that you've come up with to resolve those issues. Thank you for the summary of all the additional services AC Controls has to offer, from the field service to the panel building, and really did a nice job of showing everything Kelly Industrial Automation has to offer the customers at this point. So thank you so much for that. Again, anyone who has any additional questions, please feel free to reach out directly to Tom, myself, or as Tom mentioned, your personal Kelly Industrial Sales Associate. If you're not familiar with whom they are, shoot an email to myself or to Tom and we'll put you in touch with them. So with that being said, I want to thank everyone for their time. Tom, I want to thank you for your presentation, and I want to wish everyone a wonderful afternoon. Thank you and have a good day.